Okay, hello everybody. Today we are going to learn lesson 6.5, the last lesson in module 6, where we're going to work on comparing some properties of linear functions, even if those functions are given to us originally in different formats. So we're going to see some problems where they might give us a table to describe a function, they might give us a graph to describe a function, they might give us an equation to describe a function, and we need to be able to pick out some of the key parts like what's the domain and the range of each function? What's the initial starting value of x? What's the y-intercept? What's the slope? Some of those kind of key features that make a linear function a linear function. We want to pick them out and be able to compare them with one another. So let's kind of start in with being able to pick out some of those key things like domain, range, initial value, y-intercept, and slope. So we are going to look at example 1. And they just want us to complete the chart, okay, and assume that the domain of f of x includes all real numbers between the least and greatest values of x. So what they've done in your table is they're going to ask you to complete this table for the function that's called f of x and the function that's called g of x. So basically, that's just like their names. This function, do you guys see in the table right there how that's an f of x? This is the function f of x. They're showing you this function in a table. But if you look real close at where this function is labeled right here on this graph, that little bit says g of x, so g of x is the graph. So they want you to find these characteristics of the table and of the graph so that we will be able to compare them when we get to your extra notes on the back side. So let's talk about domain and range. When we talk about domain and range, domain means all the possible x values and range means all your possible y values. So let's do that from your chart. From a chart, to write all the possible x values, then all you have to do is look at like, hey, the x values in this table go from -4 up to 1. And they said assume that the domain includes all real numbers. So they're saying that these are the numbers that are in the table, but assume that it means all of the numbers in between there. So here's how they want you to write what the domain is. Your x values fall in between -4 to 1. Remember those little inequalities we did, where if we say this is the least to the greatest and your x can be anywhere in between? That's how we're going to write domain. And range would just be your y values. So remember, f of x just means y. There's your y values. Okay, but we do want to do this from least to greatest. Your smallest y value is -6. Your biggest one is 4. So we would say the range for your y values would be from -6 to 4. And we're just going to stick with the way that they're labeling things instead of y. They're using f of x, so let's use f of x. So there's domain and range. Let's do it for the graph. On the graph, now that you're thinking in terms of x's and y's, see how this graph clearly ends at these two spots? Look at where that's at on the x-axis. Here, I'll zoom in on the graph for a second. Okay, on my x-axis, okay, this line stretches from here to here. Whoa, that's blurry. Hang on, guys. There you go. Okay, on the x-axis, do you see how that x-coordinate would be -1? And this x-coordinate would be 2. This line stretches from -1 to 2 on the x-axis. So I'm going to fill that in. My x, it goes from -1 to 2. Okay, let me go back to the graph and let's find range for y. Okay, on the y-axis, from here to here, look at where that's at. This at the top, that's at 5, and this is at -1. So you want to go least to greatest when you guys do this. You want to do -1, g of x goes in the middle, and 5. So that's how you would do domain and range. Okay? This whole initial value thing is a little funny. They don't ask you to do that too much in the homework, so don't stress about it, but I will show you what they're wanting here. Initial value, the starting value of the functions, it's just kind of looking at what the first point would be. In this table for f of x, the initial point in the table is -4, 4. So they're saying the initial starting value is like this. F of -4 equals 4. Okay, again, you don't do that a lot in the future, so don't stress out too much about it. And then here, how your first point right there, where this starts from, is negative 1, 5. F of negative 1 equals 5. And then we need to pick out the slope and the y-intercept. So you know what? This time I'm going to start you with the graph, because I certainly hope you guys can look at that graph and tell me the slope and y-intercept, because you have totally done this before. Y-intercept, 3. I hope you're saying. And then if you count, see how that's definitely a negative slope? It's going down and over. That goes down 2 over 1. Down 2 over 1. So your slope is negative 2. Okay, but now something we have not gotten a lot of practice with. You need to be able to pick out slope and y-intercept when you see a table. Okay, we're going to start with y-intercept. Here's the trick to y-intercept. You know how we said intercepts are all about zeros? And to get the y-intercept, you make the x a 0? Look, right here. When they made the x a 0, they got negative 4. That means that your y-intercept is negative 4. So maybe you want to label that right there. Wherever the x is 0, that number that's paired up with the 0, that is your y-intercept. Promise, always. It's a rule. Okay, then for slope, here's how you do it out of a table. I want to remind you of something that I said earlier. We are so used to saying rise over run for slope, but one other way one of your earlier packets showed it is it's change in y over change in x. Change in y over change in x. So here is what I want you to do. Go across this y column, and I want you to look at how the numbers are changing. This goes down 4, minus 4. This goes minus 4. But this goes minus 2. Change in y. Now this one, do change in x. See how this goes from negative 4 up to negative 2? That's a plus 2. Negative 2 to 0. Plus 2. 0 to 1. Plus 1. And I know right now your brain's going, okay, but this doesn't make sense because these are the same and this is different and I don't get it. Okay, here's the deal. Your slope is change in y over change in x. Change in y over change in x. Negative 4 over 2. Simplify that. You get negative 2, right? So this one that you're like, but wait, this one's different. Look, negative 2 over 1. It's negative 2. So it doesn't matter what pair of points you pick. Find the rate of change and do change in y over change in x, and you will get the same slope no matter what. Slope, negative 2. Okay, let's practice this whole deal again. This time, we're going to find all the same information, but they give you f of x in a table, and they give you h of x as an equation. It's already an equation. Look, it's in slope-intercept form. Y equals mx plus b. Okay? So, let's do your table first now that you're a pro at the tables from the first one. Domain, that's your x's. These x coordinates, they go from negative 1 to 4. Range, your y coordinates, they go from negative 3. Okay, remember we're going to call this f of x in the middle. Negative 3 up to 2. Initial starting value is just, hey, what's the first point? Well, when we plug in f of negative 1, we get negative 3, first point. Okay, y-intercept. Remember the trick from up above. The y-intercept, to get a y-intercept, you make the x a 0. Hey, look, there's where the x is 0. That is your y-intercept. Your y-intercept is negative 2. And then let's do slope. Change in y over change in x. These are going, okay, plus 1, plus 1, plus 1, plus 1, plus 1. What's the other side doing? Hey, this side is going plus 1, plus 1, plus 1, It's the same pattern. Change in y over change in x. 1 over 1 is 1. Okay, this one. Okay, guys, right here, this is them giving you the domain. Look, x's can be between -2 to 2. They gave it to you. Okay, now here's your job. What you have to do is they didn't give you the range. So if your x's can stretch from -2 to 2, I need you to put in a -2 to find the lowest point for y on this graph and put in a +2 to find the highest point. So I'm basically telling you, I need you to do this 2 times. I need you to get the range by doing h of -2, like fill in a -2. That's -2 plus 1. -1. If you plug in a +2, because the highest your x can go is a 2, if you make that x a 2, 2 plus 1 is 3. So basically, your answers for h of x can go anywhere from -1 to 3. -1, h of x in the middle, 3 is your biggest. Okay, and then first point would be, hey, if you, like, since -2 is the smallest x, that's your initial value. H, sorry, not f. H of -2 would equal -1. Okay, slope and y-intercept should be easy because this is in slope-intercept form. That one, this is like y equals mx plus b. Your y-intercept, 1. Your slope, 1. So there's some practice picking out some of the key parts. Now here is more of how your actual homework questions are going to be worded. We need to flip it to the back and we need to take some extra notes. So let me give you a second to get this down. Okay, you're going to have some problems where they're going to ask you to compare an equation and a table. And we're going to do some examples off of page 230. And I think you should have these directions down in your notes. They're going to say compare initial value and range. So why don't you guys take a second, pause the video if you need to. Get this copied down and get to page 230. And when everybody's there, bring the video back. Okay, so when we look at example A on page 230, okay, this is exactly what a lot of your directions are going to look like in your homework. They're going to say, compare the initial value and the range for each of the linear functions f of x and g of x. And what's going to happen is they're going to give you the 2 functions, okay, that says the domain of each function is the set of all real numbers, x, such that x is between 5 and 8. So this is them giving you the domain. The table shows some ordered pairs for f of x. So here's f of x in the table. Do you see how the x values are 5 through 8? Because they told you the domain was going to be x's from 5 through 8. Okay, and then the function g of x is defined by this rule. So they're giving you the equation for g of x. That's in slope-intercept form. So they're giving you an equation and they're giving you a table. They want you to compare the initial value and the range. So what I want you to take a second and do with me right now is so that we have something that you can actually refer back to on your paper. Let's put down a little box around initial value and range. These are the key parts of the question. And when you're grading your homework and it says, look for these things, I'm going to be looking for, did you compare those 2 things? And I want us to go ahead and copy down the table. So I'm making an x column and an f of x column for function f of x. And in my table, I have 5, 6, 7, 8, 20, 24, 28, 32. So you write it down too. Table. And then we have g of x that's written like an equation. So copy that down too. G of x equals 3x plus 7. We have to compare initial value and range for both of these. Which means if you're going to compare the initial value and the range, you kind of need to know the initial value and the range. So let's start, okay, with f of x, okay? For f of x, it's kind of already done for you. Guys, the initial value is 20 because that's the first thing in the table. When they plug in 5, which was the smallest number you could plug in for the domain, they got 20. So your initial value for f of x is 20, and your range is going to be 20 to 32 y values. Okay? For g of x, you have to put in a little bit more effort because they say that it's for the domain 5 is less than or equal to x is less than or equal to 8. So you have to know that to get the initial value, 5 is the smallest number you could plug in. You literally have to plug a 5 in here and figure out what would we get if we did plug in a 5 for x. So I'm going to write that work down to show you. I'm going to plug in a 5, which means I will have 3 times 5 plus 7. And I get g of 5 equals, and you guys can do that in your calculator or in your head, 3 times 5 is 15, and 15 plus 7 should get you 22. That right there, guys, that is your initial value for g of x. Okay? So that gets you the initial value for what you'd get if you plugged in a 5. But if you want the whole range, this is going to be the lowest answer you could get. But you got to figure out what the high end would be too, because if you're going to get the range, you got to know, well, what if you plugged in the biggest number you could get? So you also have to plug in an 8. So we're going to do g of 8 equals 3 times 8 plus 7. So 3 times 8, 24, plus 7, 31. This is the biggest value you could get. Initial value, and then this is the largest value. So your range is from 22 to 31. So here is what you are going to want your answers to look like to hit all of the points that they want. You are going to write me 3 statements. You're going to write the initial value of f of x is 20, and g of x is 22. That covers you. Hey, I've compared the initial value. Okay, to compare the range, you're basically going to need to just tell me the range of both. The range of f of x is, and you're going to write it as an inequality. 20 less than or equal to f of x is less than or equal to 32. The range of g of x is 22 to 31. Sorry for my scribble. So when you're reading your directions on your homework and you see this and you're like, what do they want me to write? This is literally what they want you to write. This is like a model for your answer. This is what your answers should look like. Okay, and if you look at the odds in the back of the book, that's what their answers will look like. So this is like your little formula for how to write your answer. Okay, what you guys are going to see on some other ones, okay, this is the last example we're doing, but there's multiple parts here. They're going to ask you to compare a graph and a description. And you're going to have to be able to do multiple things like write a rule, compare the domain, the range, the slope, the y-intercept, lots of stuff. So you guys take a second, pause this if you need. Everybody get this down and find example A on page 231. So take a second and do that. When everybody's ready, go ahead and play it again. Okay, so on page 231, let's look at our setup here. Okay, it says information about a linear relationship may have to be inferred from the context given in the problem. This is where they want you to write a rule for each function, then compare their domain, range, slope, and y-intercept. So, first of all, We have a description of a situation. They don't give you a table, they don't give you an equation, they tell you about it. We've got a rainstorm in Austin that lasted for 3.5 hours, during which time it rained a steady rate of 4.5 millimeters per hour. The function A of t represents the amount of rain that fell in t hours. So that's why A and t, amount after t hours, A of t. The graph shows the amount of rain that fell during the same rainstorm, but in Dallas. So like, here's your little story about Austin. Here's your little graph about Dallas. Okay? So in Dallas, they're not going to tell you all this stuff, but you can find the same stuff on the graph. There's your time, there's your rainfall, you can tell how many hours it was raining for. Hey, it was raining for 4 hours. How much rain did they get? Hey, they got 20 millimeters of rain. Okay, so they want a rule for this one, and they want a rule for this one, and then they want all of this good stuff compared. So, let's try it. Okay, if we want to set up our work where we're somewhat organized and you know what in the world we were talking about in this situation. Okay, sorry for my arms everywhere. Okay, you guys, I would say maybe on your notes, let's write, here's our work for the description that they tell us, like our little story about Austin. And then let's do our work separately over here for the graph that they give us that represents Dallas. So this is Austin, this is Dallas. Do you want to write that down? Austin, Dallas, so you don't get your cities confused. Okay? All right. So, when you think about what was happening in Austin, we first need you to write a rule for each, which means basically, guys, they want an equation. Okay, so if you think about Austin, okay, they say the rainstorm lasted 3.5 hours. It rained at a steady rate of 4.5 millimeters per hour. Okay, so I hope that a rate of 4.5 millimeters per hour sounds to you like a slope, because it is. A of t equals 4.5 millimeters per hour. That's your t. Okay, and then guys, there is no y-intercept. There was nothing that said they already had this much rain, and nope, there was no starting point. That's your equation. There you go. Write a rule. Done. Okay, let's do the same thing for the graph. On the graph, instead of A of t, they ask you to call it D of t. Okay, now for that, do you see how you need a slope, like a rate of change again, but they don't just come right out and tell you, hey, here's what it is? You've got to look at the graph, and you've got to figure out the slope. So if you look at this, okay, I know some of those points in the middle are real hard to tell, but you've got a point at 420. In other words, it rained 20 millimeters in 4 hours. What's 20 over 4? Okay, hopefully there was a unanimous 5 happening. It's 5 millimeters per hour. So there you go. There's your rules. You have a rule for each. Compare the domain, the range, the slope, and the y-intercept. So here's how we're going to compare the domain. For what x values? That's your time, guys. You know how like t is kind of like your x-coordinate here in time? They told you it rained for 3.5 hours. So we aren't going to have negative time. You know what? It rained for a time period of 0 to 3.5 hours. There's your domain. Okay? However, in Dallas, if you look at your graph, how you had that point down there of the 420, it's because the time was at 4 hours. It rained for 4 hours. For 0 is less than or equal to t is less than or equal to 4. There's your domain. I'll move my hand, I promise. Okay, so you've written a rule for each. You have the domain for each. So domain, done. We need the range. Okay, so range is going to be your y values. That's harder for this one because you don't have a picture to look off of. Okay, so guys, you have to get the domain, or sorry, to get the range, plug in your minimum t value and your maximum t value and see what you would get. So if I did a of 0, guys, if it rains for 0 amount of time, You know how much rain I have? 0 millimeters. But after that full 3.5 hours of rain, A of 3.5, if I do 4.5 times 3.5, I've accumulated some rain. After 3.5 hours, 4.5 times 3.5 comes out as 15.75. Okay, so your range is from 0 to 15.75. Okay, we'll write that down in a second. Let's do this one. For this one, you guys kind of don't have to do the work, but you could get it off the graph as well. Guys, after in Dallas, same idea. If it rained for 0 hours, you got 0 rain. Okay, but if it rained for 4 hours, you already know this from the graph, so I'm just showing you for another way. But you already know that after 4 hours, it had rained 20 millimeters. So 0 to 20 is your range. Okay, so this is kind of what they want as a statement for slope or for range. They want you to write it out as the range for A of t is 0 to 15.75 and D of t is 0 to 20. So the range for A of t is 0 to 15.75 and D of t is 0 to 20. Okay, and then they wanted you to compare the slope. You're just basically going to state it. The slope for A of t is, there's your slope, 4.5, and D of t is 5. And then last but not least, they wanted you to compare the y-intercepts. The y-intercept for both functions is, look at your equations. You have a slope. You don't have a y-intercept because it's what? 0. Okay? So, guys, this is literally a model of what you want your problems to look like. Homework that you are doing for this, one more time, is off of pages 233 to 235. You guys are doing 2 through 10 even, okay? That is not very much work, okay? Not very many problems. You guys are going to do 2 through 10 even. Look. It's exactly like what I showed you. Compare the initial value and the range. So you should have for 2 and 4 the same style of answers as I gave you in that first example on the extra notes. And same thing even for number 6. Same thing. Okay, but then for 8 and 10, there it is. Write a rule. Compare their domain, ranges, slopes, and y-intercepts. So that's exactly like what you guys did down here. Okay, so there's 5 problems, guys. There's 3 of these. There's 2 of these. Okay, so we're not trying to overkill it on this, but you got to get a little practice of taking the time to kind of pick out all those pieces and put it down in a way that makes sense. So good luck with this. Hopefully this lesson will be pretty easy and you guys can do well with that. Ask me any questions when I get back, and then keep in mind that we can definitely talk about things on 6-4 if they're an issue, but use the back of the book, look at the format they're writing those odd numbered answers in, and try to figure things out, help each other out. You guys got this. I will see you Tuesday.